Hi everyone. This video is going to cover how to name the alkenes and alkynes. We had a few students having trouble naming these, so we have a few complicated problems to do here and examples. But first I'm going to briefly explain to you how to name them. If you remember from last week, the alkenes, right, they end in ane, ane, because they have single bonds, right? So when we get to double bonds and triple bonds, it is called alkene and alkyne. So the ene, the ending in ene is double bond present, and then the yne is triple bond present. So anytime we have a structure that has double bond present, the naming will end in ene, and if we have a structure that has a triple bond present, the naming will end in yne. And if it's all single bonds, which we did last week, it will end in ane. So if you guys remember, like an example we did, I don't remember how many carbons it had. So if we have a carbon chain of 5 carbons, that would be pentane, right? So if any of these single bonds is a double bond, then pentane will be switched to pentene. And if any of these double bonds or single bonds or triple bonds, then pentane would be changed to pentyne. So you guys get, this is how the naming ends of the structure. So then we got to put everything together. I'm going to erase this so I have more space to write here. Okay, so if we look at an example, here we have example 1. We have a CH3 group bonded to a CH group, and that has a double bond to a carbon attached to a CH3, and that is bonded to a carbon attached to another carbon, and then we have 5 hydrogens. So I'm going to branch out everything so you have a better view of this area, so you're not confused. So we have our CH3 bonded to a CH, double bonded to a C, and that is bonded to a CH3, and then back to the first carbon here, that's bonded to 2 carbons, so carbon 1, carbon 2. Side note here, carbons get 4 bonds total, okay? So here we have 5 hydrogens that we need to place on the carbons. The second carbon here will get 2, therefore it will have the 4 total bonds, and our last carbon will have 3. This carbon also has the 4 bonds, and that's where we get our 5 hydrogens. So we have 1, 2, 3, 4, 5. That's this one. So next we have to number our carbon chain, and we have to get the most number of carbons present. So we will have carbon 1 here, 2, 3. So where's carbon 4? Carbon 4 will not be here because that will be the end of our chain. So the carbon 4 will be here, allowing us to have a 5th carbon chain. So far so good? So what I did was I branched everything out and I numbered the carbons. The reason I did not start labeling 1 through 5 from the right side is because our double bond has to be closer to the starting point. So now, what do we have here? We have a 5-carbon chain, so that's 5 carbon is pent, right? We have this double bond present, so our pent will end in -ene. So this is just saying that we have 5-carbon chain, we have a 5-carbon chain with a double bond. And where is our double bond? It's right after the 2nd carbon, so that's why we would put a 2 in front. So we have a 2-pentene. Next, we're gonna look, let me pick another color here. We have our methyl group here. Where is our methyl group? It's at carbon 3. So that is at carbon 3 we have a methyl. So we put that together. We have our 3-methyl, 2-pentene. So our methyl group is at the 3rd carbon. We have a 5-carbon chain, the pent, and it's showing our double bond, the ene, is at the 2nd carbon. A lot of times when we have things bonded, double bonded, so we would have something here, let's name it A, and let's say this one's bonded to a hydrogen, and then we have something here, B, and this one's bonded to hydrogen. So when A and B are on the opposite sides, okay, that is trans. If they're on the same side, so if this hydrogen here was B, and this B was a hydrogen, if A and B were on the same side, that would be cis. So for this example, they're on the opposite side. Therefore, we have to put trans in the front. So going into our next problem here. So let's number. So we're going to start numbering off of where our double bond starts, so we don't have to complicate our naming process. So I'm going to start here. 1, 2, 3, 4, 5. So at 1 we have our double bond present. We have a 5-carbon chain again. We have a ring forming, and we have 2 CH3 groups. So when you see a ringed structure, how you name those is by adding cyclo in front of it. So this one is again 5-carbon chain, so that would mean for naming wise it would be cyclopent, because we have the 5 carbons, and then the ending, if it was all single bonds, it would be ane, but we do have a double bond between carbon 1 and 2 here, so our ending here would be ene. So the cyclopentene is saying we have a ring with the 5-carbon chain and we have 1 double bond. But now don't forget we have to name our 2 methyl groups. So where are the 2 methyl groups bonded to our ring? So we have it bonded at carbon 3 and at carbon 5. So at 3 we always name starting with the lower number. So we have 3, 5. So we have 2 methyl groups, and when you have 2, you add di in the front. So di, they're both methyl, dimethyl. So what does this say? At carbon number 3 and at carbon number 5, we have a methyl group. In total, we have 2 methyl groups. That's why we have dimethyl. and then we would pretty much just add the cyclopentene. And that's how you name the structure. This next example here, we have a CH3 group, so H3C is the same thing, bonded to CH2 groups of 5, so we have 5 of this, okay? And then that is bonded to a carbon that's triple bonded to another carbon. So let me branch everything out so we can number. So we have a CH3. Now we have 5 of the CH2. So we have 1, 2, 3, 4, 5. Each one has 2 hydrogens. That's where this H2 is, okay? So 1 and 2, 1 and 2, 1 and 2, and the last one. So we have 1, 2, 3, 4, 5 CH2s. This first one is CH3. All these are CH2. Then it's bonded to another carbon. And you guys see there's no hydrogen bonded here. Why is that? Because we have a triple bond. Remember, carbon only gets 4 bonds. So we have 3 on this end and we have 1 here. So it's full. It doesn't need a hydrogen. And that is bonded to another carbon. Now this carbon, the last carbon right here, has 1, 2, 3 here. So it needs another bond. That's why we have that hydrogen. So when we number our chain, we have 1, remember to start numbering from the closer side that has the double or triple bonding. So we start numbering here. 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 carbon chain. And how do we name that? So the 8 carbon is oct. So what do we have? We have a triple bond, so the naming would end in Y and E, right? So we have an octene. And if you want to be specific here, right after the first carbon, we have our triple bond. That's simple. I think this one was easier. Just another note here, the ring we did here was 5 carbon. A lot of time you'll see the 6 carbon ring and you'll name those benzene, the benzene rings. So that's it for today. Well, for these problems, I hope this video was helpful, and I hope this will help you better understand the naming process.